What's up, everyone? This is the last part in 1.2 basic classes of functions, and we're going to be discussing transformations. So let's not waste any time and let's start. All right. So now let's look at transformations of functions. So the first type of transformation I'd like to talk about are translations. So what do you think this transformation does? You have the function fx and you add h to it. If you guessed, this transformation shifts f of x up h, you would be correct. Fx minus h shifts fx, oh my gosh, I need to work in my handwriting, shifts f of x down h units. I should probably specify that we're shifting down h units. Alright, so these are the up and down transformations. Alright, now guess what this transformation means. If you guessed, or if you answered shift f of x right c units, you would be correct. You would think that by subtracting c, you would actually shift f of x left, but actually you're shifting f of x right. And now this should be pretty easy. If I add c units to x, what does that do? That shifts f of x left c units. So f of x can be any function, and these transformations will still apply, or these transformations will still translate f of x. These will always work no matter what f of x is. So when you want to translate it up or down, you just add or subtract a number outside f of x. And if you want to translate f of x right and left, then you have to just substitute x minus c or x plus c for every x value that there is inside the function. You can have multiple transformations at a time. So for example, if I write f of x minus c plus h, this shifts the function right and up. Alright? And if I do f of x plus c minus h, this shifts the function down left. I'm sure you'd be able to figure this out on your own. I assume that you already have studied this, so I'm not going to write every single direction. I don't want to take up too much time on this, because now we have to also study dilations. There's two types of dilations. There's vertical dilations and horizontal dilations. If I multiply f of x with k, I'm going to stretch it. I'm going to stretch f of x vertically. I will literally be stretching it vertically. And if I say f of k of x, you might think I'm stretching, but I'm actually compressing f of x with a factor of k. So here, k is like outside f of x, so that means we're stretching f of x vertically by a factor of k. And if you have f of k of x here, that means we're compressing f of x by a factor of k. So you can add all these transformations together. All right, so you can have f of k of x plus h, which compresses f of x by a factor of k, and then translates it up h, f of k x minus c plus h, shifts it right c units, then compresses it by a factor of k, and then translates it up. So you go right, up, and you also are compressing. It's important to know that if you are you always want to translate a function before you're compressing or stretching a function horizontally. So that's you never want to write k of x. If you write f of k of x minus c, you're not going to be shifting the function right by c units. You'll be shifting the function right by c divided by k units. C divided by k units, not by c units. So that's something pretty important to know. So yeah, those are just transformations of functions, and we are finally done with the lesson. I hope you enjoyed it. Thank you very much for watching. Hope you enjoyed it. This should be review for the most of you. But if it's not review, I still recommend you do some of the practice that I link at the description and look over the textbook. But yeah, thank you very much for watching again, and I'll see you next time. Bye bye.